Hey students, in this clip we're going to review how to find the sum of arithmetic and geometric series when they're expressed in sigma notation. So let's write down the title of this lesson. Sum of arithmetic and geometric series. Alright, let's start by taking a look at an example of the sum of an arithmetic series, okay? So our examples, number one, uh, find the sum of the arithmetic series sigma from k equals 1 to 18 of 3k plus 4. Okay? This is an arithmetic series written in summation notation, so we just have to decipher the components to input into our formula. So let's write down the formula first. The formula for the sum of an arithmetic series is given by Sn equals n over 2 times a1 plus an. Okay? So we need n, a1, and an in order to find what the sum is. Hopefully we have enough information. So what is a1? In order to get a1, what you do is you take the lower limit and you plug it into k, right? That will generate a1 for you. Okay, so let's go ahead and find out what a1 is. So we're going to plug in the lower limit, which is k equals 1, into the expression on the right. All right, so let's do that. Um, select the right color. That's fine. So we're going to have 3 times 1 plus 4. That gives us a1, which is 3 plus 4 is 7. Now to get the nth term a sub n, in this case a sub n is a sub 18 because we're going all the way to 18. To get that, we're going to plug in 18, which is the upper limit, uh, into k. Alright, so that upper limit right there gets substituted into k just as we did with the lower limit to find a1. So to do that, we're going to have on color 3 times 18. 3 times 18 plus 4, and that will give us 58. Alright, 48 plus 54 plus 4, sorry. Alright, and then also in this case, n equals, you started from 1 all the way to 18, so you're going to be adding 18 terms. Okay, so it turns out that we have everything we need. We have n, a1, and an. Now we can compute the sum. Alright, so the sum, s of n in this case is basically s of 18. We're adding the first 18 terms. So that's going to give us n over 2, 18 over 2, times a1 plus an, which is 58. And that's going to give us 18 over 2 is 9. 9 times 65. Final answer is 585. Alright? So that's basically what the sum of your first 18 terms are. Alright, now let's go ahead and try an example involving uh, geometric series expressed in sigma notation. So for number 2, find the sum of the geometric series expressed by sigma, the sum. Let me rewrite my sigma. I don't like how this one looks like. The sum from j equals 1 to 7 of 4 times 3 to the j minus 2. 4 times 3 to the j minus 2. Okay? let me rewrite this 4 times. It looks like 4 points. So 4 times 3 to the j minus 2. Alright, so let's find this. In order for us to compute the sum, let's first of all write down the formula and make sure that we have all the components that we need. Alright, so S sub n for geometric series is a1 minus a1 times r to the n divided by 1 minus r. Alright, so we need a1, we need n and r in order to compute the sum. Okay, so let's see if we have all the components we need to generate. Let's look for n first. Okay, n is the number of terms. Since we're going from 1 to 7, we're going to have a total of 7 terms. A1 is the first term, right? To get A1, what we're going to do is we're going to take the lower limit of our sum and plug it into j, into the variable right there. Alright, so let's do it. It's going to become, A1 is going to basically going to be 4 times 3 to the j, that's going to be 1 minus 2. Okay, that becomes 4 times 3 to the negative 1. Any number raised to the negative reciprocal to the negative exponent has to be reciprocated to negate that negative power. Okay, so this is going to become 4 over 3 gets reciprocated. Is a numerator with a negative power, which makes it a denominator with a positive power. So 4 over 3 is our A1. Okay. Now, what's the common ratio? This one's a little bit tricky. Whenever you have a problem like this, any number that's being exponentiated or raised to a power, that's the common ratio, because you keep multiplying by that number over and over again. So you see this number right here, this number that's been raised to a power, that is your common ratio. So this number right here, that's your common ratio because it's being raised to a power j minus 2. Okay? So with that in mind, let's determine what r is. So r is basically 3 because that's what's being exponentiated. Alright? Okay. Now let's see. Do we have all the components that we need? We have all the components we need. R is 3, so we can go ahead and apply the formula that's provided right here. So in this case, S sub n is basically S sub 7. We are summing the first 7 terms of the geometric series. So that's going to give us A1, which is 4 over 3, minus A1 over 3 times r to the n times 3 to the n is 7. And then that whole business divided by 1 minus r, 1 minus 3. Okay? So I would like to do this part in the calculator. So we're going to have 4 over 3 minus, this should be 4 times 3 to the 6th. Let's fire up our calculators and see what this gives us. So we have negative parenthesis 4 divided by 3 times 3 to the 7th power. And then the answer is negative 2916. So you're going to have 4 thirds minus 2916 divided by 1 minus 3 is negative 2. Alright? Okay, let's plug this into the calculator and see what it gives us. So we're going to go parentheses 4 divided by 3, close that, minus 2916. And then we close the numerator, divided by negative 2. Negative 2, close the denominator. Okay? You notice how I grouped the parentheses on the top here. Enter your final answer is 1457.33. So answer is 1457.33. So it's an approximation. So it's approximately 1457.33. Repeating. Okay? So there goes your final answer for the sum of the first 7 terms of the geometric series given by this expression right here. Alright, so that's that. Now we're going to go ahead and start on the first part of the classwork for today.